let f of x is equal to x minus h squared plus k, so quadratic function in a vertex form, and the linear function g of x is in a slope intercept form. And A says show that the graph is the graph of a y f of g of x is a parabola and find its vertex. Show that the graph is of a y equal the composition function g and f of x is a parabola and find its vertex. So first of all, let's go in the A. If we want to find in the A, we can find this way. Let me take a pen. And y is equal, let's just me write first in a different denotation. This is a composition function. Let me write in this 4 g of x and then is going to be this form. Now function f of x, I'm taking f of x, and f of x is equal to the, let me write here a y, because the y represent the composition function, and here instead of the x I will leave some space to plug in the linear function, and linear function is a mx plus b instead of the x. I will write here mx plus b. So I will squeeze a little bit here. I hope it's gonna fit. Good. And all this is in a square, and I have a plus k here, and is a plus k here. But first of all, before I go any further, just let me emphasize here m and b and the hk, all of them are real numbers, and k, all of them are real numbers, so those are elements of real numbers. So just let me emphasize this because it's important. And now if I move in a little bit further, I see I have m of mx plus b minus h. But in order for me, for example, to find the vertex, the x coordinate, I will take this mx plus b minus h, and I will equate with 0, and this I'm going to solve for x. Solve for x, and when I solve for x everything, so I'm not going here to demonstrate this solving for x because it's a linear equation. It is easy. I don't think it's a big problem. And x is going to be equal, so h goes in other side and b goes in other side, so get h minus b. They change the signs, and I divide by m everything, so I got the x coordinate. And now if I want to find the vertex is going to be this way. The vertex is h minus b x coordinate over m. They can be any real numbers and they can be combined, and then we divide everything and we find one real number and k. So we found the vertex. And this equation here represents the equation of the parabola. So in a b, if we are going to the b, and b is going this way. So now we have this function here, this composition function to write. So y is equal with the composition function g of f of x. So g of f of x. So this function here we have, and I can write this way. Again, it's important here, those m, b, h, k are elements of real numbers, and they're going to show up in here, so I'm not going to rewrite because already I stressed out here those are real numbers. So now first g, I'm taking the function g here, and I'm writing m, and instead of the x, I'm plugging a whole this formula here, and just let me write here a big n is x minus h. X minus h is here. M times x minus h squared plus k. and is plus b is outside, b is here, the b is outside. And if I am multiplied everything, just let me rearrange a little bit everything, and the m is going to be in the front of x minus h, x minus h, and this is going to be square, and m type k is going to be plus mk, plus mk, and plus b. And now if I'm finding the vertex here, so this is a quadratic function. Here I have in the vertex form, but now the k, what it used to be just a k, I can substitute mk plus b. I can write it just with one letter, just with one parameter. But if we wanted to write the vertex of this parabola, how is going to be? The vertex is going to be h, the x coordinate, and the y coordinate is going to be mk plus b, mk plus b. And mk plus b, we are plugging in some numerical value, and we multiply, add here, we are going to find one numerical value, and of course h one numerical value. So this is the form how we can verify in both cases when we work with a composition function with a parabola and linear function. In both cases we get a quadratic function respectively. It represents the parabola, and we already verified those vertex. We found the vertexes.